All right, guys, let's do number 8. So I'm going to write the velocity component. So the velocity component for this one is going to be v equals 5 meters per second in the I-hat direction. And notice that there's no acceleration in the x component, so that's going to just be, that's always going to be 5 meters per second. So that's going to be a constant velocity plus a changing acceleration. So that's just going to be, or in this case, 3 meters per second squared times the time in the j-hat direction. And then the acceleration here is going to be 0 meters per second in the I-hat direction, 3 meters per second square in the j-hat direction originally. So a velocity of the, okay, so for part A, it's going to ask for the vector position of the and the velocity of the particle at the function of time at t equals that. So this is going to be the, this is going to be the velocity vector. Now we're going to find the position. So the position here is going to be 5 meters per second square times the time in the I-hat direction minus 2 over plus 1 is going to be a 2 divided by half plus 3/2 meters per second square times t squared in the j-hat direction. And yes, folks, I am writing the whole units. So that's going to be part A. Part B is the coordinates and the speed of the particle at 2 seconds. Now, notice that it is set coordinates and speed. Well, the coordinates is just going to be, all right, so the coordinate is pretty straightforward. It's just plugging in the r vector at 3 seconds. So let's find that vector. So r is going to be at 2 seconds, so that's going to be 10 meters per second, or I mean 10 meters. So that's going to be times 2, that's going to be 10 meters in the I-hat direction. And that's going to be 6 meters in the j-hat direction. Now that's the coordinate position. That's where the particle's position is. Now let's find the speed. So the speed is just going to be, well, the vector first is going to be 5 meters per second in the I-hat direction plus 6 meters per second in the j-hat direction. So that's just the velocity. It wants the magnitude. So the speed is going to be the magnitude of that position. So that's going to be 6 squared plus 5 squared, which is going to be 25. 36 plus 25, square root of that thing. Once you add them up, of course, it's going to be 7.81 meters per second. Do they want the... No, I think this is right. The coordinates and the speed. And I guess if they want the magnitude of r, let's just put that in there. I don't know what they want in terms of its coordinates. I mean, I think the vector should be enough, but I'm going to write everything down anyways. So this would be 11.67 meters for that one. 10 inverse of 6 divided by 10 is whatever that angle spits out. So that's going to be 30.97 degrees. All right, we're done.